Hello! In this video I want to continue our discussion of the mean, or the arithmetic average. I'll refer to it as both the mean and the average. And as we saw in the last video, you can calculate the mean, which we represent the sample mean as x bar. Okay, this is the sample mean. And we calculate that as the sum from the ith observation, or the first observation, to the nth observation, where we sum up the values of x and then we divide by n, or our sample size. And this was used, we used this to calculate the mean for an array of data where we just had a list of several numbers. Well, we can do the same thing for a frequency distribution. Okay, calculate the mean for a frequency distribution. And we can just change this formula just a little bit so that we'll make it easier to work with a frequency distribution table. And what you'll find is that when we have a frequency distribution, we're now going to sum the value of x times f. So we want to calculate the value of the variable x times its frequency first, and then we'll divide that, the sum of those values, by n. And so the easiest way to do this is just to create an example, and we'll show you what we're talking about here. Let's say that we have a variable. Let's say this variable is x, and we've got a frequency distribution, and our variable looks like this. We've got values of 2, 3, 4, and 5. And we've got a frequency distribution that has frequencies of 5, 7, 4, and 2. Okay, so our sample size then is the sum of the frequencies. It's 5 and 7 is 12, plus 4 is 16, plus 2 is 18. Okay, so we've got a sample size of 18. Now, you could think about this frequency distribution as being a collapsed version of the array of numbers. So realistically, what this array really refers to is we've got values that are, 2, 2, 2, 2, 2. There are 5 2s, and then 3, 3, 3, 3, 3, 3, 3, 7 3s, 4, 4, 4, 4, 4 4s, and so on. Then we've got 2 5s. Okay, so this is really what the data distribution looks like. But instead of working with adding up each of these numbers individually and dividing by 18, we can shortcut that using the frequency distribution. And what we're going to do is we're going to create a new column called x times f, or xf. Okay. Now, if you think about it, what we're trying to do is we need to know what the sum is for all of these values in this array. We need to know what the sum is. And to calculate the sum of all the 2's, we would add 2 plus 2 plus 2 plus 2 plus 2. Well, we could do the same thing by simply multiplying 2 times 5. So the value of x times its frequency. So we'd have 2 times 5, and we get a value of 10 here. And then 7 times 3, we get a value of, there's 21. And then 4 times 4 is 16, and 5 times 2 is 10. Okay, so now we've multiplied x times f, and that gives us the sum of all the observations in each of these values of x. So there are 5 2's, and when you add them all up, 2 plus 2 plus 2 plus 2 plus 2, we get a 10. So if we add this column of numbers together, add the xf column together. Note that's our numerator. We want to have the sum of x times f. So if we sum this column up, we get 10 plus 21 is 31, plus 16, 31 plus 16 is 47, plus 10 is 57. And so we get a 57 here, and that's equal to the sum of x times f. Well, now we can compute our average. Using our formula, the sum of x times f in the numerator, we know that the sum of x times f is equal to 57. And we need to divide that by our sample size n, and we've got the sample size here of 18. And that's going to give us then 57 divided by 18, which means we've got an average of 3.17. So somewhere in here, right, x bar is equal to 3.17. And we can visualize this, if we want, using a histogram. If we were to draw a histogram out here for our data, where we had values of 2, 3, 4, and 5 for our variable x, and we had the frequencies here, and let's say we went 1, 2, 3, 4, 5, 6, 7. We could draw a histogram here. We'd see that there are 5 2s, that there are 7 3s, there are 4 4s, and there are 2 5s. And we would find that our average, or the mean of this particular sample, is going to be 3.17. 3.17. And so in our histogram, which is somewhat normal, but it's a little skewed, right? We've got this peak that's a little bit pushed to the left, and we've got a longer right-hand tail. And so we've got a distribution that's just skewed just a little bit. And our average is pulled just a little bit to the right of the mean because of that. And so this is one way that you could visualize the average on a histogram. And this is an example of calculating an average for a frequency distribution table, where we multiply x times f first, the value of our variable times the frequency, sum up those frequencies times the values, and then divide by n.